I would like to welcome you all to the discussion forum to observe the International Year of Glacier Preservation 2025. So this discussion forum, we will be discussing about science, prediction, and response to glacier decline in mountain snow and ice. As you all know, as we are celebrating this International Year of Glacier Preservation, IYGP 2025, we would like to also welcome Professor John Pomeroy, and more we will be talking about it later. But we have, besides in-person participants, we would also like to mention here and welcome all our online participants. We are also recording this session, and we will be posting it in IYGP website and also linking it with all the partners' websites also. This is a half a day session, and I hope you all will enjoy and learn quite a lot about IYGP and the impact of climate change on glaciers, snow, and permafrost of our region in the mountain. To move ahead, I would like to request Dr. Pema Jamso, the Director General of ICIMOD, for the welcome remarks. Dr. Pema, please.
Good morning and namaste. I think we are at a very special moment in time, a moment in time where we can make a difference. This International Year of Glacial Preservation offers us one, I would say, ultimate opportunity to get together and address this critical issue of the impacts of climate change. Distinguished guests, colleagues, and friends, it is a great honor to welcome all of you, those in person here as well as those attending online. We are very, very happy that we could have Professor John Pomeroy to come and address us on this very important topic, the International Year of Glaciers Preservation 2025, Science, Prediction, and Response to Global Decline in Mountain Snow and Ice. Now, Professor Pomeroy is the co-chair of the IYGP Advisory Board, but more importantly, I think he is the director of Water Futures Program. I believe that water is the future, and future is water. Climate change impact is all about water, either too much or too little water. We need to address both. Too much water, floods and disasters, destruction, loss of lives and properties. Too little water is the same. Droughts, impacts on crop productivity, food security. So all these are challenges that if we can address the challenges, the issues around water, we would be able to address quite a lot of the impacts of climate change. Therefore, it is it's a great honor for me and for all of us at ICIMOD to welcome you, Professor Pomeroy, at our campus. I'm also very happy to see our Professor Suresh Charlisi. I always used to regard him, when I first joined ICIMOD way back in 2003, I think. That time, he was leading ICIMOD's work on hydrology, on water and energy. And I used to spend hours and hours listening to him. And that time, of course, with a pinch of salt, because I didn't really realize that water is going to be that important in a decade or so. Now, reflecting back on our discussions, I could see that he was truly farsighted. So thank you, Professor Charles, and great to see you in good shape. The Hindu-Kush Himalayas, as you all know, I don't need to repeat, is at the front line of the impacts of climate change. Our glaciers are melting very fast. Snow line is retreating. Tree lines are going up. So all these events are happening right in front of our nose. The threats from glacier lakes, outburst floods are increasing. So all these are things that you have heard over and over and over again, and I will not repeat again. So what we need to stress here during the discussion is what can we do individually, collectively, as a nation, as a region, as a global community, as professionals, as investors, as academics. Everybody needs to work together, especially our youth. I'm very happy that we have such a big group of youth attending in person as well as online. Just as water is the future, you are the future. So you need to take leadership. Yeah. I'm sure you must have heard it again over and over from me as well as from our other colleagues. We have thousands and thousands of glaciers. The estimation ranges, from 54,000 to 72,000 and so on. But the important thing is our glaciers are not located elsewhere, somewhere very far from the settlements. Our glaciers are right within the vicinity, within kilometers of where we are living. Huge density of population. So when you talk about the poles, the third pole, the North Pole, South Pole, and the third pole, what is different? What is different is we are a peopled pole. We have people living in the Hindu-Kush Himalayan region. So that is why the urgency of action is very much here. We need to take immediate and urgent actions. So for our researchers, for people working on cryosphere monitoring, we all know that so many glaciers are still not being monitored. Now, I understand that only 38 have currently monitoring stations, permanent monitoring stations located on them. So without better data, our ability to project changes, support adaptation, and inform policies is severely limited. We must expand glacier monitoring, improve data sharing, and enhance access to high-resolution satellite imagery to develop robust climate strategies. So it's so very important. We cannot have just pockets of data. So we are very happy that now, for the first time at ICIMOD, we have cryosphere scientists from all our cryosphere countries. All the countries with glaciers, we have now a good team representation at ICIMOD. Now we have from China, we have from Bhutan, we have from India, we have from Nepal, and we have from Pakistan. So we do hope that we can put together a complete picture rather than just one snapshot of a picture. So we will hopefully in the coming years, coming decades, with support from all of you, we should be able to have a more comprehensive picture of what is happening and what is likely to happen. The International Year of Glaciers Preservation, IYGP 2025, therefore, as I mentioned in the beginning, offers us an unprecedented opportunity to spotlight these issues at the global level. It's a chance for us to reaffirm also ICIMOD's role as a regional leader in cryosphere research and action. This forum is a critical moment for us to exchange knowledge, build partnerships, and identify the actions needed to protect our glaciers. I look forward to hearing the insights from Professor Pomeroy, who will share with us today his broad knowledge about the subject and also provide us strategy, guidance, and direction. I encourage all of you to actively participate in this discussion. Thank you.
Thank you very much, Dr. Pema, for your welcome remarks and making us realize that we have been witnessing climate change and other drivers of change impacting our cryosphere. That is snow, when we say cryosphere, snow, glacier, and permafrost in this region. And we need a collective action, and an urgent action is required. Thank you so much. With this, let us move on. By the way, I am Neera Shrestha Pradhan. I am leading this portfolio on cryosphere and water at ICIMOD. Again, welcome you all. Moving on, I would like to request Mr. Bhavani Shankar Dangol, Executive Director of the Small Earth Nepal, to introduce the Nepal National Glacier, Water and Weather Week in the context of IYGP. As the world is celebrating IYGP in Nepal, what we are doing. Bhavaniji, over to you.
Thank you, Niraji. Distinguished Professor John Pomeroy, other distinguished guests, and all the participants, namaste and a very good morning to you all. Very pleased to introduce about Nepal National Water and Weather Week to you all. Even though many of you know already about this week-long program, I will just share briefly. So we all know that March is an important month for us, working as we are working towards water, climate change, glaciers, and so on. So we have 22nd March as a World Water Day and 23rd March as World Meteorological Day. And we were celebrating and we are celebrating this for many years. And more importantly, from this year, we have World Day of Glaciers. It's on 21st March that we'll be starting from this year. So we have also theme of World Day for Glaciers and World Water Day as a glaciers preservation. And for World Meteorological Day, we have theme closing the early warning gap together. So World Day of Glaciers. So March 21st, as I already mentioned, is declared as World Day of Glaciers to celebrate annually from this year, and also declared the International Year of Glaciers Preservation. So we have been collaborating with different partners and stakeholders for this collective action. Since 2009, under the chairmanship of Water and Energy Commission Secretariat, the government of Nepal, we are celebrating a week-long program to celebrate World Water Day and World Meteorological Day. And that was also decided by the cabinet meeting of the government of Nepal in 2014 to celebrate World Water Day every year. So from this year, we will also add World Day of Glaciers in that week-long program, in addition to World Water Day celebration and World Meteorological celebration. The Small Earth Nepal is serving as a secretariat for coordinating this Nepal National Water and Weather Week. And from this year, we have discussed and agreed to make it Nepal National Glacier, Water and Weather Week. So most of you are already present here as a collaborator, partners and stakeholders for this program. And mainly we are working with government institutions, INGOs, UN agencies, academic institutions, youth clubs, different societies, as well as individuals. As I mentioned, I just wanted to show how many, this is not the complete picture, but we have, varieties of partners and stakeholders from different, government and INGO, NGOs, institutions, and so on. So they are supporting us, collaborating us in celebrating this week-long program every year. So since 2009 to 24, our major programs in that week-long program are focused on awareness raising activities, publications, publicity, research work, sharing of research results and knowledge, policy advocacy, and capacity building trainings. Some of the pictures shows that activities. And also news post, news in the media. We do about different programs that time. And for this year, we have discussed, and we are also discussing about focusing our programs on bridging science, policy, and communities, gaps in science, policy, and communities. And of course, awareness with different digital and print media to raise awareness. I'm just linking some of the initiatives of Small Earth Nepal towards glaciology and cryosphere. So we are doing some research projects. We have done international conference, and we have done some research on Everest region, high altitude mountain regions. And we are collaborating with UNESCO headquarters in Nepal. And we are also just like to inform that we have launched the World Water Development Report last year, and we are translating that into Nepali, and we will be launching that. And also, more importantly, preparing new generation with capacity development. And these are some of the programs being discussed for this year. So I will not go into that detail. So thank you.
Thank you very much for providing the details about how Nepal is going to celebrate the International Year of Glacier Preservation and the International Glaciers Day. Along with that, ICIMOD is also organizing various events in the HKH region. And one of the major event is the campaign that we are doing on Save Our Snow. So we are moving ahead with other activities also. Now, moving forward is the time that we would like to introduce John Pomeroy. To do that, I would like to request Dr. Dheeraj Pradhananga, Associate Professor at Tribhuvan University and the Chairholder, UNESCO Chair in Mountain Water Sustainability, to please, yes.
Thank you very much, Dr. Neeraj Shrestha. I'm very much honored to be here, and especially in the presence of my all gurus, including Professor John Pomeroy, Professor Charlie Say, Dr. Madanlal Shrestha, and all of you. Namaste and good morning to everyone who are here now and also online participants. It is, in fact, a great honor to be here and welcome you to join these open forum discussions. That is what we named for this one. And this is an important event where we come together to talk about glaciers, water, and climate change. These are the issues that affect all of us. So this is what I say is not just a talk program, but also a platform. And it's a chance to share our knowledge, ideas, and commitments as well. And particularly to tackle the biggest challenges that we face, the rapid loss of snow and ice in our mountains. We are starting International Year of Glacier Preservation 2025 in short IYGP, and the UN Decade of Action for Cryospheric Sciences with John's presentation today and the open discussion on the importance of mountain snow and ice on water resources, food, and energy security, as well as disaster risk reduction. So this event is also a part of UNESCO Chair in Mountain Water Sustainability. John Pomeroy is a primary chairholder of the bigger effort that we started a few years before, and it is a unique one. And I am also one of the shareholders representing Nepal, and we have others from Chile and Canada. So I'm very proud and glad that this is one of the events of like Bhavani Dongol mentioned. It's the first event leading to the Nepal National Glacier is added here. So Glacier, Water and Weather Week. Normally we celebrate that, as he explained, 23 to 17 to 23 March every year, and which is chaired by government of Nepal. So I'm very much glad that the committee added a glacier, which is a very important part, and it highlights the importance of snow and cryospheric sciences. So before I want to, take a moment and consider that how I got some guidance, and I truly appreciate the contribution of Professor John Pomeroy to hydrology, climate science, and mountain sustainability. Definitely, it's an honor to be here to reflect some my personal reflection on him. He is more than a PhD supervisor to me, but he's all for my professional career. Especially, he's my mentor, he's an academic guru. More than that, he has been a guide and source of strength in my career. There were times, as everybody faces, there were moments when I thought of not continuing what I was doing. And there were several steps, especially I faced huge challenges in my PhD. And even after finishing my PhD, I had a lot of challenges. And he's the one who never gave up on me. And his support, encouragement, and belief on me helped me to come back and work, continually working on the field that I'm leading. So his mentorship is not just about science. It's about building confidence, thinking critically, and making a real impact. So because of him, I'm standing here today and continuing my work in hydrology and mountain sustainability. So now let me take a step back from my personal connection and formally introduce Professor John Pomeroy. Though many of you already know him, especially his groundbreaking work, I would like to introduce him few of his achievements, starting with Dr. Pema, Director General of ICIMOD, also mentioned about the most important part of this year is International Year of Glacier Preservation, and he is a UN co-chair of the IYGP Advisory 2025 Advisory Board. And as I already mentioned, he's a primary shareholder of the UNESCO chair in mountain water sustainability. At the University of Saskatchewan, he is the Canada Research Chair in Water Resources and Climate Change. He's the director of the Center for Hydrology and director of the Cold Water Laboratory in Canmore, Alberta, and Smart Water Systems Laboratory, Saskatoon, in Saskatchewan. He serves as the director of the Global Water Futures Program, as Director General of ICIMOD mentioned in his welcome remarks, which is the largest and most published university-led freshwater research project in the world. And as it continues, it follows on the Global Water Futures Observatories project. I hope John will be mentioning briefly on that as well. And one of the important network that he is leading, international network of alpine research catchment hydrology, which I admire a lot. And I'm also helping him to expand the network in this region, especially in the Himalayan region. So John Pomeroy was the 2021 recipient of Walter Langevin Lecture Award for Hydrology from the American Geophysical Union 2019 recipient of Myslo Romanowski Medal for Environmental Science from the Royal Society of Canada, and 2017 recipient of J. Tuzo Wilson Medal for Geophysics from the Canadian Geophysical Union. So these are the few awards he received that I mentioned, but there are a lot that we don't have time to mention here everything. So he has served as the co-founder, in fact, the founder and the president of the International Commission of Snow and Ice Hydrology of ICE. I'm now one of the vice president of the commission. So he is the chair of International Decade for Predictions on Gauge Basins, president of the Canadian Geophysical Union, and he was also the first professor of hydrology in Wales at the University of Wales, average state research scientist with Environment Canada and the USDA Forest Service and NATO Science Fellow at the University of East Anglia, England. Dr. Pomeroy has authored over 400 research articles, reports, and several books that have been cited over 25,000 times. His pioneering research on glacier hydrology, snow dynamics, and climate change impacts has shaped global scientific discourse and influenced policies worldwide. He has led international efforts to bridge science, policy, and communities in tackling climate-driven water challenges. Most importantly, his work embodies a passion for understanding and preserving our fragile mountain environments, something that deeply resonates with all of us here today. So in the final, today, in fact, we are incredibly fortunate to have him here with us. His presentation on International Year of Glaciers Preservation 2025, Science Prediction and Response to Global Decline in Mountain Snow and Ice, which will be very much a critical insights into the challenges and opportunities ahead. So let us take this time not only to listen and learn from him, but also to engage and exchange ideas, because the future of our glaciers, water resources, and mountain communities depends on the actions we take today. In fact, he introduced me to so many platforms and global platforms, and I really feel privileged or honored to introduce him formally over here. So with that, it is my great honor to welcome Professor John Pomeroy to the stage. John, the floor is yours. Thank you very much.
Okay, thank you. That was the kindest and most fulsome introduction I've ever had in my life, and I should never forget it. It's a great delight to be here in Nepal, as one of the most beautiful countries on the planet with the most hospitable people. I was so happy to come here the first time and the only previous time in 2009 at the invocation of Mr. Jagat Busal, and then introduced the Himalaya region. And so it's wonderful to be back. So thank you. I'm here to speak about something that, okay, it's a glacier year and some science and things like that. And so this is all very interesting. But in fact, if we don't make progress on controlling climate change and preserving our glaciers, I don't think we will survive as a global civilization, and perhaps not as a species. And so the importance of glaciers preservation and preserving our cryosphere is fundamental to the continued existence of humanity. And so please keep that in mind as I discuss the science and the policy implications. So the United Nations has passed a resolution proposed by Tajikistan for an International Year for Glaciers Preservation. Why did they do this? Well, we have rapid deglaciation and loss of mountain snowpacks going on around the world. These are recent results published from the Glamby team showing glacier mass change from 2000 to 2023. And so the size of the circle gives you an indicator of the glacier mass in that region. And the red is the amount that has been lost since the turn of the century until 2 years ago. And so we see globally 5.4% of our glacier mass has been lost in a quarter century. But we see regionally, some areas like Central Europe and the Alps, 38%. In the Canadian Rockies, where I'm from, about 23%. And when we go into the Caucasus, 35%. And starting to look at Southeast Asia, the Himalaya region, 21%. So there are some very high regional values. Also, there are some areas that are not experiencing large glacier loss yet, but are about to. And a particular interest would be the Antarctic, subantarctic, and the Greenland periphery. These are just starting, but the impact on sea level rise will profoundly affect countries which have no glaciers, such as Bangladesh or Sri Lanka. And for small island states, in fact, many will disappear within the lifetimes of people in this room. So what I cannot overemphasize the global disaster that this is, and also that global snow and ice provide fresh water for about 2 billion people on the planet in some form. And the loss of this ecosystem service will make some of our agriculture, our energy supplies, and our communities unviable and unlivable. So this is the year we have to turn this around. And to preserve glaciers, this means reducing greenhouse gas emissions, restoring the warming of the planet to below 1.5 degrees Celsius, so we can still keep some of this function. So the impacts extend far downstream of the glaciated areas. Snow cover is also retreating around the world. These are satellite measurements of snow-covered area and the number of days per year that is snow-covered. And so you see a few places where there's been increases in blue, but mostly we see decreases of up to 15 days over the period from 1972 to 2022. And of particular interest are high mountains throughout Western North America and Alaska, some of the high mountains in Asia, in the Caucasus, in the Alps, and in Western Siberia and Japan. So this is another global phenomenon. And of course, for freshwater supply, the melt of the seasonal snowpack is the greatest global contribution to freshwater supply in the cold regions that are shown in this area. So this is what is affecting downstream irrigation, downstream hydroelectricity, downstream water supply. So stepping back to the year of glacier preservation. So we know the UN adopted the resolution proposed by Tajikistan. We were very grateful for them for doing that. And we now have a World Glacier Day. The first one will be March 21st this week. And I'm delighted to see that Nepal is celebrating this very vigorously, as it should be. We also now have this year where we can raise global awareness of the critical role of glaciers, snow and ice in the hydrological and climate systems, and the impacts on the economy and society and the environment. And also it gives us a chance to share our best practices and our knowledge and our information across this year. So we have an advisory board that I am co-chair with, along with Dr. Carolina Adler of the Mountain Research Initiative in Switzerland. And we have a remarkable, wonderful secretariat composed from the World Meteorological Organization and UNESCO, and then these 19 members along this, including Nira, who is the lead for Task Force 2 that I'll get into in a bit more in a bit here. But this is a very good group and is moving things better, moving things forward better than my best expectations at the beginning. So the task forces, there are 4 of them that are organized to coordinate the global effort for the year. So Sarah Manueli from FAO leads the global campaign for the year. Nira Shrisha Pradhan leads the International Conference on Glaciers Preservation, the regional workshops, and the capacity building. This is absolutely crucial for the year. And James McPhee from University of Chile, the research and monitoring, the science aspects, and Pam Pearson from ICCI and the policy advocacy. but there are many others from ICIMOD and others in the audience here who make large contributions to this, including Diraj and Miriam Jackson. And so I'm so grateful for what you do to move this forward. It is a global effort. When we look at the timeline for the year, 1 year is very, very short. And so we've had the launch of it already online on January 21st. And now we're moving up towards the World Glacier Day component with parallel celebrations in Paris at UNESCO with more of a policy and programming and science aspect, and also some high level, but then a UN member state led component at the UN General Assembly also on World Glaciers Day in New York. And so those are moving forward very vigorously. And then we will have the International Conference on Glaciers Preservation hosted by the sponsor nation, Tajikistan, in Dushanbe at the end of May, beginning of June. And I hope you're able to travel to Dushanbe for this very important meeting where we will put the substance on the year. And then we have further events, the International Mountain Conference, the various American Geophysical Union, the European Geophysical Union have discussions on this. The Canadian Geophysical Union does. And so they will have a closure event and some significant inputs at COP30 in Brazil to move that forward. So one thing I'll mention here is that we also have the launch of a decade, which I won't talk too much about other than to mention it's happening, because you can see in a year is hard to pack all this in. But the decade has also started in 2025, and it's the International Decade of Action for Cryospheric Sciences. And this runs from 2025 to 2034. And this encompasses the whole cryosphere. So the high mountains, the snow-covered boreal forest, the Arctic tundra, the snowpack, the sea ice, the Antarctica and Greenland, the massive ice sheets, and the permafrost thaw that are affecting the whole planet. And it's that loss of cryosphere which is really losing a crucial element of the Earth system, which makes our planet habitable. So the team has put together 13 key messages for the glacier year, and I won't read them off, but you can read them on the big screen here, and you see there's very many important things, and so many of these I think will strike a chord in Nepal, and certainly with ICIMOD as strategic to our various operations. And so the communications are focusing on these various themes. So I'm a scientist. I'm a hydrologist and glaciologist. I'm a field person. I've been doing field studies, and I still do, on the high mountains and glaciers and the Arctic and in the prairies in Canada and elsewhere from time to time. But I also build hydrological models and try to keep them as realistic as possible. And I work with my many students who are the real engine of getting everything done. But so I try to answer this impossible question: what can science contribute to mitigation, adaptation, risk reduction? Because even as we mitigate and hopefully reach agreements and start to lower the greenhouse gas concentrations in the atmosphere, and I have to say we're not at all doing that right now. We're heading in the opposite direction, which is a suicide as our species. But I'm always an optimistic person, and I think we'll sort it out in time. And hopefully in time for a bit of the cryosphere. But in the meantime, we have to look at the changes that are occurring in the high mountains, the changes to our snowpack, the thaw of permafrost, the impact of warmer climate causing more rainfall rather than snow. The change in vegetation as forests move upwards in elevation or burn at lower elevations and disappear. And then, of course, the decline of our glaciers and the additional water from glacier melt, ice melt, which is contributing to our stream flow right now. It did not necessarily in the past, if we go back half a century or a century, and it will not in the future as our glaciers disappear. So we're becoming dependent upon that glacier ice melt, just as a drug addict becomes dependent on the drug, but the drug is disappearing. So we're going to go through withdrawal, and it's going to be ugly. And of course, the altered river flows from the changing snowpack, the changing precipitation, the altering glacier and elsewhere, and the disasters such as Glofs, glacial lake outburst floods associated with sometimes with debris flows, sometimes with changing glacier dynamics and ponds associated with them. So we need many things. We need to observe better in the high mountain cryosphere what's going on. We need to diagnose the causes of this and be able to predict these. We need early warning systems for extreme hydrological events. And we have to identify community and sectoral vulnerability to risk. And then finally, we have to develop risk management solutions for adaptation and risk reduction. And many of these things we've been working on in the Global Water Futures program in Canada for the last 9 years, but they're very relevant to this program. So for observations, the world does not have enough high elevation observations of meteorology, of hydrology, of the snow, of glaciers, of groundwater. And we need to improve these. It's very hard to maintain this. ICIMOD and Nepalese government have direct experience of this. And the one group that Dheeraj mentioned is INARCH, the International Network for Alpine Research Catchment Hydrology. It's part of the GWEX, the Global Energy and Water Exchanges project of the World Climate Research Program. This brings together the high altitude research basins around the world, which are concentrating development of this. And you see a cluster in the high altitude Asia, the Himalaya and Tibetan Plateau region, but we need more. And so I certainly invite people with instrumented basins to join INARCH. It's a fantastic program. Its budget is zero. It works on cooperation and collaboration and sharing of information and helping each other. And but we also have new satellites that are proposed and being developed, which may help with measuring mountain snowpacks around the world. With the Department of Environment Canada, we're testing sensors right now at my field site in the Rockies towards development of a terrestrial snow mass mission that I hope will be launched maybe 5 years, 6 years, and will help us with getting mountain snow and ice where we can't measure this. And finally, open sharing of data. We cannot possibly manage our shared mountain water resources if we do not share the data, which allows us to do so. So in Canada, we have the Global Water Futures Program, the observatories facility of that, and we operate this as a freshwater early warning system across the country. And this includes 64 instrumented research basins across Canada, from the Great Lakes region where most Canadians live, to the prairies, who are very cold, to the high Rocky Mountains, and then to the Arctic, to the mountains and in the Yukon and the Northwest Territories. So these are a wide variety of stations. There might be a mountaintop station measuring meteorology. There might be snow measurements. They might be measuring microplastics or harmful chemicals or environmental DNA in the laboratory. There might be lake samples. There might be drones flying LiDAR to measure things. So and I'll zoom in on one part of that. We call the Canadian Rockies Hydrological Observatory. This is in the UNESCO World Heritage Site for the Rocky Mountains of Canada. And it's one of the largest in the world as a World Heritage Site. And we have 35 stations at high elevations in this region, which help us quite a bit. I also want to recognize, you'll see occasionally in this some artwork. The artwork is from the artist Gennady Ivanov. I strongly believe that art is a way to connect our heart and our minds and to communicate our science outside of the scientific bubble that we're often speaking to. And we're publishing with Gennady Ivanov and my co-author, Professor Trevor Davies of the University of East Anglia, a book called The Great Thaw. And we're publishing this with UNESCO. It will come out next month as part of World Glacier Day. And so it'll be online and a few physical copies if you get to Paris. But if you want one, I'll send you a copy for free. So at Peyto Glacier, it's one of the World Glacier cries for watch stations. It's been an international hydrological decade observing basin since 1965 with intensive scientific observations. It's also, most importantly, where Dheeraj did his PhD research. And unfortunately, where he did his PhD research is disappearing and will certainly be gone perhaps this decade. But one thing we've done lately, we have some stations on the ice and below the ice and stream gauges, and we fly this drone with LiDAR on it. So we can very carefully measuring what's happening in this area. And I'll show you some very shocking results. The last 5 years have been bad years for Peyto Glacier. So one thing is from this, we can get the glacier flow rate, which is very, very useful. And we can see that it was about 5 years ago flowing about 7 meters per year. And that's accelerated to 8.5 meters per year over time. So drones can give you very useful measurements such as flow rates from following the rocks. So that's kind of nice. But then it also gives us an idea of the disintegration and the breakup of the glacier. There's a lake, a proglacial lake, which is formed there. It started about 2010. We call it Lake Monroe after Professor Scott Monroe, who studied Peyto Glacier with Gordon Young for so many years and really one of the pioneers of glaciology in Canada. But you see where the glacier was in 2019 and where it is just in last year where we took these measurements. It's retreated about 2 kilometers from the early 1950s. It had been retreating about 10 to 20 meters per year, but we had a heat wave in 2021 in Canada where the temperatures in Western Canada hit 49.6 degrees, an all-time record high for Canada, and the places that measured that burned down the next day in a wildfire. But the retreat rate is accelerated for 1 year to almost 200 meters per year. And now we've lost about 440 meters in the last 5 years. So a tremendous retreat. But the LiDAR information also gives us some idea of the change in the vertical elevation, the surface elevation of Peyto Glacier. And that is truly profound. So some of these numbers are low because the ice disappeared very quickly over 5 years, but some are high. Where we have 56 meters of surface lowering over 5 years. That's because of collapse around an ice cave there. More typically, it's about 35 meters of ice melt occurring on Peyto Glacier over the last 5 years, melt lowering the ice surface, which is dramatic. It's creating enhanced stream flows in the headwater basins, and it means the end of Peyto Glacier very soon. We can also measure the 1 year loss of both moraine and the ice core moraine around it. And you can see some of that is melting out quite a bit, 30 meters of loss in 1 year. And then at other places where there's landslides, some gain depending on slope movements. So there's a lot of geomorphology, very, very active moving along here. But we have lost also in 1 year, very, very large amounts in melt rates from 4 to 8 meters of loss. Of ice height lost in one season. So this is very, very bad. Of course, this last summer was extremely warm again. Every year is another record hot temperature. And we had massive wildfires in this area that destroyed much of the national parks in Canada and the Canadian Rockies and destroyed part of the town of Jasper in Jasper National Park. So very devastating, but hard on the glaciers. And what we found through the research of Caroline Aubrey-Wake and Andre Persicini was that the ash and soot from the wildfires on the ice accelerated the melt rate 3% in the year of the fires. The smoke slowed it down a bit, but the year after about 10%. And it's 10% acceleration of the melt rates. So things are coming together. The heating causing the melt, the wildfires accelerating the melt by dropping the albedo and pushing things in a very negative direction. So some summaries for Peyto Glacier, if you like numbers, and painting that will be a front piece on the Great Thaw book from Gennady Ivanov, showing the fires in the sky, the darkened ice, the newly formed proglacial lake, and the end of Peyto Glacier coming. And as you can see, it's very grim statistics indeed. So how can we diagnose and predict these things? Well, we can use models along with these measurements, and as long as the models have a strong physical basis, then we can use these to apply scenarios for the future. We can understand which is occurring. And in fact, this was the basis of Dheeraj Pradhananga's PhD thesis, was to add realistic glacier components to hydrological models and use these to diagnose places like Peyto Glacier, the Athabasca Glacier. And he did such a very good job on this. It's developed a model that has, I'll show you some of the results, been very, very powerful. And now also components of this are put into continental scale hydrological models, which we can use on a global basis. But the future flows, this is the Athabasca River near Jasper, Alberta, and part of the headwaters of the Mackenzie River Basin. And the baseline of stream flow is in yellow, but the future flows, if the glaciers were held constant, are in dark purple. And this is under climate change worst case scenario with some uncertainty built into it. But if the glaciers retreat to what they're expected to be by the end of the century, we see a collapse in late season stream flow here. This is an absolute disaster for this region that is already suffering so much from fire. And so I'll go into more of this. In global water futures, we had a multi-modeling strategy. So part of this was developing the cold regions hydrological modeling platform. This was key to have Dr. Pradhananga there for his PhD work to further develop this modular system to make it suitable for glacier environments. But we also took that information and in parallel built this into a larger scale modeling system we developed with the Environment Canada Department called MESH. And this is a coupled land surface hydrological and now glaciological model, which we can apply over very large river basins. And then we have a next generation modeling system we call the Canadian hydrological model that my student Chris Marsh developed. He's now a scientist with Environment Canada. And this I will go into a bit, but it has potential global application at multiple scales and is designed to run on supercomputers very, very quickly. So first, the cold regions hydrological modeling platform, it was developed as a modular object-oriented modeling system starting in the late 1990s. We continue to develop it. We have the glacier modules and avalanche modules and different albedo models thanks to Dheeraj Pradhananga's research. And then Caroline Aubry-Wake and Andre Bertoncini continue work with this. And this is from some of Caroline's work on Peyto Glacier, just showing the various processes that are included in the CRIM model. We call it CRIM for short. And so we have fernification from snow to firn to ice, sub-debris ice melt, all the snow processes, blowing snow, intercepted snow in the forest canopy. I have a student, Alex Chbosky, working on the snow interception and sublimation, improving that right now. We have groundwater in the model, stream flow generation, infiltration, all the processes there. And it's coupled to the energy flows as well. So we ran this for Peyto Glacier, forced with a model called Weather Research and Forecasting, or WRF, at a climate model run at 4-kilometer resolution. We find if you don't have high resolution climate model runs in the mountains, it's almost impossible to do anything reliable. So 4 kilometers begins to capture some of the adiabatic processes, the orographic processes, the wind flows, and then we also get a accurate representation of precipitation. And so this is from some of Caroline Aubry-Wake's research, showing a future Peyto Glacier at the end of the century forced by WRF with our RCP 8.5 forcings. And so we get an increase in evaporation, increase in rainfall, decrease in snowfall, collapse in blowing snow transport, snowmelt not too different, soil moisture higher in the winter, lower in the summer, groundwater storage peaking earlier, but the stream flow response is very interesting. We'll zoom into that. So this is a stream from a currently glaciarized catchment that would be largely deglaciated. And so stream flow drops about 7%, but in June it rises 93%. And in July it drops 53%. So it's this tremendous shift in timing of the stream flow. The peak flows decrease about 1/3, but they're occurring 1 month earlier. And then we'll have winter stream flow, which we don't have any of right now. So it's a very strong shift in the hydrology of that basin, but it's a small basin in the high mountains. And so we need to understand better how this translates to downstream water resources as well. For this, we use MESH, the Canadian Hydrological Land Surface Scheme, and MESH can be fed by climate models. It can be globally applied. And it has as its core the Canadian Land Surface Scheme, which has lots of snow processes. We have frozen ground processes in it. We've added glacier processes, blowing snow. We've added a component called Mountain Mesh, which addresses slope and aspect, elevation bands, and other things. And this is some of the mesh analysis for snowpack in Western Canada, so we can run this over very large regions as well. It has been adopted by the Government of Canada as a national water model for the National Hydrological Service of Canada. These are just showing you some of the continental simulations that we can do with MESH, modeling the snowpack over the continent over here, the subsurface storage, including groundwater over here, and then stream flow over here, just as an example. And that's for 500,000 basins over North America. So it does have that global capacity. And we're hoping through collaborations to help groups in setting this up for larger areas. We've done some testing in the Himalaya with this in the Upper Ganga River Basin, and they were promising, but as the Global Water Futures Program has come to completion, we weren't able to fully complete those. So we'd like to work further there. We are working with the Indian Institute of Science in Bangalore. So we'd like to do more with this. We set it up above Calgary, Alberta, in the Bow River Basin. This is in the Canadian Rockies. So Peyto Glacier is just up here, and the rest of our observatories in here. I won't go into the details, except that there's a lot of work to set it up very accurately for this particular region. And Calgary is a city of 1.6 million. It's had severe floods, and it has a large irrigation zone downstream of it. So irrigation is very important for food production in Canada, in the West, and it's derived from these mountain snow and ice resources. So it's a good example. So one thing, we're able to put in the glaciarized fraction along the mountain foothills through here into the model and include that in the model. This is forcing, again, with the WRF model for the mesh to get the Bow River Basin at Banff with a minimal calibration, only 3 parameters on soil moisture and some routing through here. And so for forcing from an atmospheric model against real streamflow measurements, I was very, very happy with those results, particularly with the very little amount of calibration in there. And so this is over the historical period, just to give you an idea that, yeah, this thing does sort of work. And then we can take this and calculate future stream flow at Calgary with different forcings. And so this is comparing with WRF for the current and future period. And we see the shift in stream flow, the reduction in summer flows, which would be very problematic for irrigation, the increase in winter flows. And then we tried forcing it with an RCM, which is 40 kilometer resolution downscaled to 10, but it's too coarse, and we don't get the floods. We don't get quite the droughts or the proper response to there. So even with a statistically downscaled RCM, it's still very dangerous to force models like this. So now we had an experiment with to try to translate this to Asia, and so we thought, well, where the water problem is very severe, and the Sir Daria Basin in the Central Asian republics has terrible water problems, emblematic of the shrinking Aral Sea, which is disappearing, but also the high mountain waters in the Tien Shan and massive hydroelectric and irrigation. And MESH has irrigation and reservoir development built into it as well. So it's able to handle these areas. So we'll zoom in on the Sir Daria River. And for this, we set up 5,900 subbasins in the Sir Daria. We did some testing in the Upper Naran and on the Ala Archa Basin. We're able to verify the model operation of the Ala Archa, transferring the parameters from Canada quite successfully through there. And then we decided we take some forcings and from ERA and from EM Earth and perturb those. But again, showing with minimal calibration some of the comparison of it to simulated and measured streamflow and snowmelt period. It's suitable for this task, I think. So, but the future looks grim. This is it under RCP 8.5 with perturbation of ERA5 and EM Earth. And we see a decrease in snowfall, increase in the rainfall, and an overall decrease in precipitation, which is very bad. A very large reduction in the snow water equivalent, the peak dropping 45%, and the snow-covered season shortening by 3 months. And then when we look at stream flow, we see the peak discharge dropping 35%, the peak date moving forward 1 month, and the summer discharge dropping 50%. Now, in this case, we've run them with current glaciers and removing the glaciers because there's still some uncertainty how many glaciers will be left in that region at the end. So the future lies somewhere between the red line and the blue line. But you see, that's the deglaciation effect. The rest is the climate change effect, which has a tremendous impact on the snowpack. So it is a change in snow in the Sir Daria Basin, which is primarily driving this change in water resources. You notice that a change in peak sweep of 45%, and we get a change in discharge of 45%. So it's quite linear response. But when we look at the overall water resource accumulation over the year, from now, 45% drop with a small difference depending whether it fully deglaciates or not. So so even though the glaciers are incredibly important in the headwaters, it's the glaciers and the snowpack that are driving that particular system that we have to stay aware of in its change. So another model I'll mention very quickly is the Canadian hydrological model. This is our hope for the future. It's a modular, multi-physics, scalable, high-performance computing model. It's very spatially explicit. You can run it at resolution of 50 meters, so it can capture snow drifts It has all the physical processes in there: radiation, wind flow over complex terrain, blowing snow, snow interception, frozen ground, and we're adding the hydrological processes to this now, and full energy balance for snowmelt. And it has a variable resolution. So the meshes, it operates on these triangles, which become very fine in areas of interest and very coarse in areas of less interest. And we can vary the wind flow through it with a wind flow model. We have various models built into it. It's modular again. I won't go into the details. In this case, we force it with the numerical weather prediction model from Canada at 2.5 kilometers resolution. And because we use these variable resolution triangles, we get we go from what would have been 3 billion raster cells grids to only 34 million triangles over a vast area of Western Canada. That's what makes it globally applicable in time. And we want to do that with collaborations here, ultimately in the Himalaya. This is an example over a small part of the Canadian Rockies, and you can see the snowpack developing and then blowing and then avalanching down the slopes on the windward slopes through here, and then melting away. And of course, the last snow to melt is that avalanching snow. So because we have this avalanching of blowing snow built in, we can grow glaciers in an accurate way. And because we have shading, remote shading and self-shading of slopes, we can also look at the slope and aspects on glaciers and their calculation. So this is a type of modeling capacity that I think will be crucial for future modeling in high mountains around the world. And we're able to deploy this over a vast region of Western Canada. This is in a forecast system we call Snowcast, which can give us an early warning system. And this it's the type of system that could help with glacier lake outbursts, rain on snow, and snow droughts. We need that high resolution, high accuracy, physical accuracy to be able to do this. And I think forecasting systems that build in snowmelt, glacier melt, and downstream aspects are crucial, but they had to be tied into the institutions who share the early warnings in an appropriate way. In this case, we share the data with the Canadian and Alberta governments for their early warning systems. So I mentioned community and sectoral vulnerability. We learned in Global Water Futures, it's crucial to co-develop solutions and vulnerability indices with communities. So the model predictions, the modeling itself is not enough. The science itself is not enough. You have to work with the communities to find what the tipping points and the thresholds are in various communities or sectors. It's crucial to bring in Indigenous community and remote community knowledge into these systems and into these solutions. To build them without them is not servicing them appropriately. And we have to build capacity whilst we're doing this. So we have been working with Yukon government, for instance. Yukon is a small territory in northern Canada, has only 50,000 people, and they now have a fully developed flood forecasting system to help them. So, and then finally, communities never forget equity, gender, and justice issues in these things. We can take models and information like this to develop risk management solutions with communities. We can couple the hydrological modeling that I've shown to hydraulic modeling, which allows us then to map floodplains and flood risk. And this is something very important to map future flood risk so that our communities can be designed in a safer way. And we have to be able to communicate the uncertainty with this as well. And communicate that down to municipalities and local regions so they can design safer communities so that reservoirs can be operated more safely. And then finally, with some art from the Great Thaw from Gennady Ivanov. Warning, two paintings here. This is Kluane Lake in Yukon Territory. The Slims River drains the Kaskawalsh Glacier off the St. Elias ice field, or it did, until 2016, when the retreat of the Kaskawalsh Glacier caused a diversion of its meltwater from the Slims River to the Alsek River, which drains now into Alaska. So you've heard maybe President Trump saying he wants Canadian water. He's already getting some Canadian water from this, it's called river piracy. It's already occurred. The glacier did it on its own. Glaciers have their own minds, as you know. So, but it was very bad for this lake. This is a UNESCO World Heritage Site. And you see the dry lake bed here. This is in spring. The snowmelt alone is not enough to feed this lake, and its lake levels dropped almost 2 meters. And the harbors were all left dry. The Indigenous people could not fish. It's not coming back. These are the types of dramatic changes we're seeing around the world. This is another one. President Trump talked about the great faucet that he calls Canada. And so here's his faucet. This is part of the Columbia River system. It's a reservoir called Kinbasket Lake. And that's a dust storm painted in the middle of the reservoir. There's no water in it because of a snow drought. And we've had exceptional snow droughts, and the glaciers alone are not sufficient to fill these reservoirs in recent years. And so the hydroelectricity generation has dropped dramatically across Canada in 2023. And also the water exports, the natural water exports to the United States, much lower. So we may think as humans that we control the world and control things. No, no, no. The glaciers and the snow and ice control things. They're in charge. We better listen to them. And we have to work together to find our sustainable future. So there's a website for the International Year of Glacier Preservation. 2025 is a year where we have to turn this around. And I'm hoping in the future that we can look back, and despite all the chaos and the noise that's going on in our planet, that we can say that some fundamental decisions were made this year where we started to turn the planet around to create a future where some of our ice and snow can still survive and where humanity can still survive. And I look forward to working with you on this grand adventure. Thank you.
Thank you, John, for presenting science-based challenges, problems, as well as solutions with some actions. So this is the time for discussion. Like I said, this is not only we are talking, but we are also making some commitments and some, the actions that we can do in the future related to IYGP or UN decade of actions for cryospheric sciences. So the floor is open, and I hope that you may have some questions to John's presentations, or you may have some comments to make or commitments to do, and something that you want to share. But please be brief so that there are more people joining us today, so they can have opportunity to share their thoughts as well. So the floor is open, and especially he has welcomed that we all can join the IYGP. So there is a web link John has provided. So let's also join that. So I would like to open the floor for discussions and and the question answer session as well. So John will be responding them, and if it is related with other activities also, maybe we can collectively respond as well. Yes.
Thank you very much. This is Govinda Bahadur Sai. I am representing from Tribhuvan, Nepal, one of the co-organizers of this event as well. And I am also representing from Mountain Partnerships as a vice chair from representing civil societies. Thank you very much for this very nice and scientific presentations with the data and fact. But I am representing civil society, and I have always one thing in my mind, and I am being so worried about that. Because of this climate change, our freshwater tower, mountains, and glaciers are being so in critical stage. But I am so worried, how can we convince the world political leaders to focus for preserving these important things? We have seen many news, many statements by the leaders. They are not so much concerned about that. So as being the scientist, as being the advocate, how can we convince them?
Thank you. Thank you, sir. Would you like to respond?
Yes.
How we convince the leaders?
Yeah, thank you. We have to have the leaders at high-level meetings where they're exposed to this. We also have to show the full global implications of the loss of mountain snow and ice. One is on sea level rise. So we already have several centimeters per year due to the melt of the mountain glaciers that are causing rising sea levels. That, with expansion of the oceans due to heating, is causing problems in many cities around the world. In Miami, it's already flooded almost all the time. There's more to come, much more to come, as the Greenland and Antarctic ice sheets start to melt rapidly. Then we're looking at meters of sea level rise, and there's high uncertainty in this. Some of this could be much faster than we think. And so there's a wide range in outcomes from there. But I think as a scientist, we've got to look at the high range of that, which can be meters perhaps in the lifetime of people in this room. So this puts an end to places like small island nations. This puts an end to Florida, much of Florida, to East Anglia in England, to much of Bangladesh. They become underwater. And perhaps the richest areas build seawalls, but the rest won't. So this is a serious, serious problem. The other is delivery of fresh water for agriculture, for hydroelectricity, which affects billions of people on the planet, and really the viability of both rich and poor countries. And it transmits the impacts out of the high mountains, thousands of kilometers downstream into areas which are remote from glaciers, but profoundly affected by them. And the great example in Asia would be the Indus and the Ganges River, but also the major rivers through China, which all arise in the high mountains, and the Mekong is Southeast Asia.
Thank you, John. Dr. Arun Bhakta Srestha. The mics are here.
Thank you, Professor Pomeroy. Very informative presentation. I'm Arun Srestha, Senior Advisor, Climate and Environment Risk at ICIMOD. Quite comprehensive, so there are a lot of questions. I'll put only a few. One is very technical on the surface change of Pelto Glacier. On the moraine part, I saw also positive change. So I could not understand, is it due to mass movement?
Yes.
A few more. The in-arch initiative seemed quite interesting. Would be good to know what it is and how we can participate and what could be the benefits, like, institutions in this part of the region. And the last one is, you talked about snow, you talked about glaciers. I did not hear about permafrost. I assume it's quite important in Canada as elsewhere. In this part, we do not know quite a lot about permafrost, and we are just initiating the work on it. So maybe some words on permafrost would also be very helpful. Thank you very much.
Okay,
Three questions.
thank you. Yeah, the three-part. So first, for the surface change, yes, you saw ice core moraine melting and surface level dropping, but also the effect of landslides occurring there. So where the elevation go up, that's because the land has slipped down the steep hillsides around the glacier. And so we have both going on. And of course, one of those landslides someday might dam the lake and create a Groff situation. So it wouldn't surprise me at all to see that in that environment. So then the other is INARCH. So the International Network for Alpine Research Catchment Hydrology was a group of high mountain researchers who came together and said, well, we have these high observation sites. We all have problems maintaining them, and we want to have better models associated with them. But it became much more than that. It became a way to diagnose what's happening in the high mountains by integrating observations and models. And it informed the World Meteorological Organization's High Mountain Summit in 2019 towards development of high mountain observation and prediction systems coupled to societal services. It's a project of the World Climate Research Program, and it's open to anyone to join. And so the INARCH website was back on the slide there, and or you can get it on the web, but we look forward to that. And we have, through Jirej, some collaboration on some basins in Nepal and many in China through the Tibetan Plateau Institute, the Chinese Academy of Sciences, and also Hohai University. But we'd like to expand this more in Asia. And we're having a meeting at the International Mountain Conference in Innsbruck, Austria, in September. So we're having an INARCH meeting 2 days before, and then a session at the IMC as well on the high mountain observations and predictions and what we can learn from them. So the models I showed you have all been involved with in INARCH, and many tested in South America and in Asia and even in Africa and across in Europe and throughout Asia. And permafrost, finally, permafrost, yes. We have permafrost built into both CRIM and to the mesh model. In the mesh model, it goes down in 26 layers to 50 meters, calculating the heat and mass transfer between liquid water, ice, and soil through there. And so we've run this over the large northern basins in Canada, like the Mackenzie River Basin, which is second largest in North America after the Mississippi. And we have to grow the permafrost first. So we have to run it many centuries in cold climate, and then we get the permafrost grown, and then we run it forward to the end of the century. And we have shocking results. In the northern basins in Canada, 90% loss of permafrost by the end of the century under RCP 8.5, which will cause ecological devastation. The soils there are half ice, half dirt. And so once the ice melts out, the landscape collapses, the forests fall over. That's called drunken trees. And they often catch fire and burn after that. And we're already seeing this happening. It also causes towns to collapse, roads to collapse, pipelines to collapse, runways to collapse, and it's all happening right now. So it's devastating for Northern Canada to be losing this. In the mountains, we know less, and there's less ice-rich permafrost in the mountains, but the destabilizing of mountain geomorphology by loss of ice means more rock avalanches, more debris flows, and more sediment transport, including conditions that can create roughs. So we know they're tied together, but we need more work on that in particular. The final thing I'll add is that when the permafrost is gone, then you have more groundwater activity. And so the increase in base flows in the cold season is partly because of that loss of permafrost.
Greenhouse.
Oh, yes, a tremendous emission and dangerous emissions of methane in particular from permafrost. There are ponds in northern Canada you can set fire to the bubbles coming out of them, and it's just burning out of the ground now. And this is methane that's been locked in for millennia, is now being rapidly released to the atmosphere. This is also gas hydrates under the frozen ocean, which are being released as sea ice goes and subsea permafrost thaws. So many problematic things occurring rapidly. That's why I keep showing RCP 8.5. I think realistically, we're going to see these natural feedbacks of greenhouse gas emissions, such as methane from the permafrost, that'll be worse than we have anticipated, even if we control some of our carbon emissions.
Yeah, thank you, John. I think we have several online questions as well, some participants from online participants. So maybe we can start with yes, we can start with Arundhati. So the question is on related with winter flow and decrease in summer flow. Is it because of winter is shrinking?
Yes, it's happening because the winters are warmer. We're getting rainfall events every month in the winter, rain on snow events, and also thawing of frozen ground, which allows groundwater movement to feed into base flow into the streams. But those stream flow peaks are because of rainfall and snowmelt events in the winter, so a warmer winter.
So Dr. Prakash Vishwakarma is asking whether there is any innovative water management solutions to address that sustainability of long-term ensuring for the affected communities.
Yes, one thing people always ask, what can communities do to preserve glaciers? And of course, rich countries can put fabric on top of them like they do in Austria around ski areas and bits in Switzerland, but it's not practical on a large-term basis. One thing, the ice stupas developed in Ladakh and parts of the Himalayas are a nice way to store some ice in the winter by freezing liquid water flowing for melt in the warm season, but these are small-scale solutions. So for larger scale solutions, you can also use nature through preserving wetlands and natural lakes. One thing we found very important in simulating the future hydrology of Peyto Glacier was the future depressional storage. So how much water is held in lakes and ponds is very important for the future hydrology. And so this is something that we can also make sure we don't drain them and that we leave room for them. And then some countries are looking at greater reservoir movement development as well, because in some countries it's a matter of shift in timing, and they want to hold the water back a few months until they can use it for irrigation. So it will depend on the society. Some of those solutions, if you build a reservoir that's very expensive, you're going to flood a valley. The valley probably has people and ecosystems in it. What happens to those? Those are big problems too. When we use nature-based solutions such as wetlands and ponds, then this has more beneficial capacities. In Canada, one way to help compensate for the loss of the glaciers is to not kill the beaver. We have beavers in Canada. It's an emblem of the nation. Beavers build dams. And that's what they do. There's little dams all over the place, thousands, millions of dams. and it can hold back vast amounts of water in the mountains. And so one of my colleagues, Sherry Westbrook, studies that and shows this can be very effective at flood control, but also groundwater recharge to get that the meltwaters into the ground so they can be abstracted later and provide base flow in dry seasons.
So there are several questions. We have, I think, 10 more minutes. So maybe you can start answering, how traditional knowledge and practices of indigenous communities to be integrated in a scientific approaches. So that is one of the questions. Maybe you want to start from there and then we can address the rest.
Yes, there are a variety of traditional and indigenous knowledge and practices that can be brought in. In Japan, they have the phenomena known as yukigata, or snow shapes. And during the melt of snow in the mountains, certain shapes form in the mountains, maybe like an old woman and a plow or something like that. And the farmers know this is the time to plant rice, or time to do something else in the field. So many societies have linked snow and glaciers to their traditional practices. To find solutions for the future, we have to integrate these practices into what we know. Some indigenous societies have very profound things. The Haudenosaunee people of Eastern Canada, in their traditions, talk about the horned serpent coming out of the ground that would destroy the world. And they interpret this now perhaps as the carbon emissions from oil and gas from very time. So there are some important things. In the Himalaya, we have you have traditional societies, indigenous peoples that have been managing the waters for thousands of years in a sustainable way. And the learning from those people and the framework, the context there. So we say, you're right, it's changing. How things are done in the past may not work in the future, but how you understood to do things in the past will be crucial with the science to form the future. So something in Canada we call braiding of traditional and scientific knowledge together, I think, is a very good way forward. And finally, the concept of thinking forward many generations, looking back 144 years, looking forward 144 years. The Indigenous people in Canada think forward 7 generations and say, what are you doing now that helps people 7 generations forward? And the politician thinks 5 years at best. So we've got to move beyond that in how we govern our societies to adopt some of those longer term perspectives that come from our Indigenous and religious and social systems.
Yeah, so one of the questions was because you presented several models, so which model is best for downscaling and especially at the basin scale? So maybe you quickly answer that, and then I'll take the last question.
Okay. My colleague Al Pietranero, who I worked with on these models, says they're all bad and they're all wrong, but sometimes they're useful. So remember, they're just tools. And so it depends what your problem is. If you have a small basin and you want to diagnose and understand it very well, then the cold regions hydrological model is a good way to do that. And I can teach students in about 3 hours how to operate and set up a model from scratch. If you have a national modeling need with basins of tens or hundreds of thousands of square kilometers, then the mesh model is very good. And for the future, I think the Canadian hydrological model will be something that can be perhaps applied globally. And it has that scalability to it, but it requires very powerful supercomputers and commitment by national governments, or even groups of national governments, maybe coordinated by UNESCO and WMO for global application. And it can be multi-scale, to go small scale to large scale. But remember, they're all just tools. So I think we've got to find a way. But yeah, you can run CRIM on your laptop and learn it in one afternoon. And it's a good way to get going. And Dr. Pradhananga has trained many students in Nepal already who are running this successfully in Langtang and Langesha Basin. So that's a nice way forward. Mesh is harder, but we're running this, both of them in China right now, very successfully. And in South America, we're running all 3 models. We have Chilean universities, University of Chile, James McPhee, but for different purposes. So again, it depends on what tool you need.
To summarize last 3 questions, it is related with climate adaptation. And they were asking, what could be the local level policies or local government policies that you can advise in focusing on Nepal, especially because they were concerned with the retreat of glaciers?
Yes, the key thing will be resiliency to, you're already seeing increasing in floods and increasing in droughts between floods. Expect more of this and expect more extremes. Expect the drought resiliency that came from glaciers to diminish as they start to retreat more massively in mid-century and later century. Do not become dependent upon the extra water resources that the glaciers are providing right now. As I mentioned, it's like a drug addiction. You don't want to get addicted to something that's not going to last, and it will not last. And then finally, the solutions often need to be implemented in communities, but you need to think like a river basin from the top to the bottom of the basin. So communities in the river basin working in some harmony can help move forward there. And these are great challenges, the greatest challenges of perhaps of humanity's existence. But perhaps one thing to remember is that humans are very, very effective water managers. Since we developed as a species, we started to mess with rivers and get water from the ground and irrigate when it was dry and do other things. And so this is a water management challenge, and hopefully I think we're up for it, and we can make the impacts of this less than they would be otherwise through wise water management, and remember to build sustainability for the future generations in what we do.
Thank you, John. We still have 4 minutes, so if any of you, Dr. Pemba, yeah. And then Miriam. So we'll quickly take 2 questions, and then I think we will be ready for the wrap up. Yeah.
Okay. Good morning, everybody. I'm Miriam Jackson. I'm the Eurasia Director at ICCI, International Climate and Crisis Initiative, and also with the Norwegian government, and formerly was at ICIMOD. Thank you very much for your talk, John. And I was also lucky enough to hear another version in Paro. And I was wondering, you showed what can be done when you have a lot of data and a lot of cooperation. You showed that especially for Canada. And how do you convince people that monitoring and data are important, that, you know, we can get a lot of information from satellite measurements, but the in situ measurements are invaluable. We also need them as well. And my second question also is, we've been working with Asian Development Bank, and they have a lot of projects like glaciers to farms, and they said glaciers are the hook. And then you go on to snow and permafrost, and snow's not always as exciting, but in many regions, much more important than glaciers, and permafrost is a term most people don't know. And you sort of did that here. You drew us in with glaciers, and then you moved on to snow.
Yeah.
So yeah, those are the 2 questions. Thank you.
Okay. Yes. Canada is a funny country. You know, it's very big and doesn't have many people, and most of the people live in the south. So the southern part of Canada is well monitored. It has a monitoring density similar to Europe in different areas. Northern Canada has some of the lowest monitoring density in the world. It's poorly gauged. And so within one country, we have the example of good monitoring and very poor monitoring, but we still need to predict water. So for instance, the Yukon River Basin is the size of Germany, and it has 25 stream gauges and about 15 weather stations. So, and that's one of the good ones. It gets worse as you go to the Arctic Islands. So we've been working with the governments and communities to convince them that having a station at the high elevation above it helps them. The town I live in Alberta, Canmore, was devastated by a rain on snow flood. Deerage was there, and you know, very, very bad destruction around town that was badly forecast. So this is in 2013. So the town now operates 2 weather stations, one in town, one up in the high mountains above town, to help with the provincial and federal forecasting in that area. But but also these events, when extreme events occur, then that's the time to communicate to governments that they need more monitoring in the top, and that the more monitoring they have, the better the predictions will be. And that means the flood damages will be reduced, the drought damages will be reduced. And if they're generating hydroelectricity, then you can optimize hydroelectricity and become wealthier. So you have to tie it into the economy in some way, and that's one way to do that. Then the other was to tie in for the whole cryosphere. And glaciers are beautiful, and glaciers capture our attention, and they're in our heart and souls. But when we talk about the whole planet, then we have to think about sea ice. We have to think about permafrost, which is being lost. We have to think about how do we save our snow. And so these are profound. In Canada, you know, the Great Lakes, where a lot of the people live, they have algae blooms. in the Great Lakes. Well, why are the algae blooms worse? Well, it's partly because farmers apply too much fertilizer, but it's also because the lake ice is diminishing. There's less lake ice. And because there's less snow cover, there's more winter rainfall, which is washing soils containing phosphorus into the Great Lakes. So even areas that don't think they're too connected to the cryosphere are very strongly connected to the cryosphere. We have to build those connections, and we have to build it to the sea level rise. So people understand that the extra damages from storms in big cities where the wealth and power is around the world, or simply massive numbers of people, that this is the cryosphere responding to what's happening on the planet.
Thank you, Joe.
Thank you.
I think we can take last question from you, or question or remarks.
Thank you very much, Professor, for the excellent presentation. Just one practical question. I want to throw this question to you because I often get this question, whenever I travel around. Now, yes, for the Himalayan countries like Nepal or Bhutan, water is the most important resource. So the question is now, with the impending threat, the vulnerability to global, governments are facing the dilemma of whether to go for, investment in the hydro, which you mentioned just now on the hydropower sector, or whether to, sort of be more cautious and avoid the risk of having these major hydropower plants, especially, with rivers that are glacial fed and that are highly exposed to global events. What would be your advice to these, the policy makers or decision makers, especially in relation? Now you have just come back from Bhutan, I heard, and you're now here in Nepal. So if you can share your thoughts on this, thank you.
Yes, I think this is something that social scientists call a wicked problem, because we need more clean energy, non-carbon emission energy. So hydroelectric is very appealing from that point. But hydroelectric in mountains is dependent upon the mountain hydrological cycle, which is fundamentally changing. So we cannot use the assumption of stationarity and constant climate in the past to design the facilities that will operate in the future. So we have to be able to assess survivability. But we also have to look at risks when we have GLOFs, when we have avalanching and landslides, such as occurred in India and affected major river and destroyed the hydroelectricity there, and where we have earthquakes. There are very high risks with these facilities as well. And so finally, we have rivers are important systems. In some parts of the world, rivers are declared equivalent to human beings. And it's something we need to think about very carefully before we dam all of them. That would be a sad, terrible thing to lose all the mountain rivers in our quest for clean energy and maybe our quest to reduce risk and manage water differently. And we'll see some benefits, but not everything can be for humans. We have to leave something for the environment as well. And the problems we're seeing now is because we've been too much for humans in the past with our carbon emissions. So in our solutions for that, let's not make it worse. And let's not increase our risk downstream of dam failure as well. So I think select areas, careful areas, it makes some good sense. It can be beneficial. In other areas, maybe better to look at other renewable sources as well.
Thank you. Thank you, everyone. And before we wrap up, we have two eminent scientists from Nepal, and we would like to listen to them. First, before that, also, I would like to also announce here that today, in fact, John and I jointly supervise one master student from the Institute of Engineering, Prasanna Dakal. I think he's here. He has applied a cold region hydrological model and looked at the impact of black carbon in the Langtang River. So first, I would like to request Dr. Madan Lal Shrestha, academician, Nepal Academy of Science and Technology, and also advisor to the Small of Nepal. So Madan sir. Thank you.
Yeah, good morning. I think it's a great pleasure to listen to Professor Pomeroy. And I'm also happy to see my respected guru, Professor Salisi sir, and all the distinguished friends. I think when I heard about this one and when Dheeraj asked me about that, I'm really excited to share some of my thoughts. And when we talk about the glaciers, because I'm a meteorologist by profession, but I became involved in glaciology by the field work. As soon as I joined my office, within a year, I was sent to Hidden Valley, from Kathmandu to 5,500 meters. And we stayed for 3.5 months there with our Japanese team. And that was the first time that Nepal entered into the snow and glacier exploration. And I'm happy that, I was involved in that at the inception phase. So I think only in this morning, I was talking with ICIMOD colleagues that they are going in October this year to Rikasamba Glacier in the Hidden Valley again. We started in 73, still it is continuing. And so this is some of the things I think which really admire. And I'm very happy that ICIMOD is very active in that one. And in that one, and not only the ICIMOD, and we can see in that area, even the Kathmandu University, even the Tribhuvan University are working on that one. So this kind of study is going on. But even before that, there are some studies, sporadic studies, because I remember, because I met one of the, maybe Professor Pomeroy might know, Dr. Fritz Mueller, and who is, I think, a native in Manali, in India, in the, the Center of Snow and Avalanche Studies. So I think that is a good facility. And he came to Nepal and worked in the Everest area in, I think, 1958. And he was really excited. And that is the time when he was moved and he concentrated his effort in the cold region hydrology. So these are some of the studies that we find. Maybe there may be some other, but the systematic research and studies started from early 70s. Actually, for that glaciological expedition in Nepal, the fieldwork started in 73, but the homework has started even from 1969. So I think at the time, the Department of Hydrology and Meteorology is very happy to join that one. And the government deputed me and sent me with our Japanese colleagues in that area. And to tell you the truth, that changed my life. I mean, I was a weather forecaster, so I was looking at the weather, but then suddenly within a year, I was in the snowfield. That is very exciting, especially to work in collaboration with the Japanese scientists who are very much experienced in this kind of a field. And for me, I think as a meteorologist, we talk about the conduction of heat. Now we are looking at the conduction of heat in the glaciers. So these are some of the things I think I would like to, I'm very happy. But the thing is, I think as we hear from Professor Pomeroy and our Director General that, there is the glaciers are, we are losing the glaciers. And the topic seems very exciting to see it as a preservation, but I'm wondering how we do preserve. But definitely, some of these groundworks that we are doing and some of the groundworks I think the Professor Pomeroy has indicated, I think that is really going to help. And so I am really enlightened with the talk that Professor Pomeroy gave. And when he talked about the disappearance, the glaciers are vanishing. And I think the last year we had a conference in Kathmandu University. And when we talked with our Japanese colleagues also, who have been going to these, the Sorong Himal and the Hidden Valley. In Sorong Himal, I think you might have heard about AX010. And they say that maybe in a decade's time, that glacier will not be there. And once it is lost, means it is lost forever. So it is a big concern for all of us. And in that one, I think from the research point of view, the Kathmandu University, Tribhuvan University, and ICIMOD is really going forward. But I think I would really like to see, of course, there are some collaboration going on, but I think these institutions should come together and do more work in the collaborative work, because the university is a place where we have the human resource. If you look at the Kathmandu University, ICIMOD is very much helping in that one, in getting the master courses and even the PhD courses in that one. So I think, we heard that, it also involves with the economy. When we look about nowadays, we have the mountain-specific tourism is very much developing. But with the vanishing of these snow areas and the glaciers, I think there will be a lot of impact in that one. I think that definitely, along with the use of this glacier water in the hydroelectric generation, in tourism, in agriculture, etc. But the disaster part is also there, as we have seen in the Gulf. And the government is, I think, very much proactive in this case, because after minimizing some of the risk posed by the glacier lakes, like Imja and the Sorolpa, now government is moving forward to work on another 4 glacier lakes in the Gandaki Basin as well as in the Kosi. So I think in that way, I think the government is also moving forward for that one. I'm very happy to see that, before we have the Nepal National Water and Weather Week, now another one later has added with the glaciers. I'm very much happy to see that one, and I hope, I think that NNGWWW will be very much effective in, I think, bringing together all the actors who are working in the water, glaciers, and this weather science. So I think with this, I end my talk. Thank you very much.
So before we conclude, I'd like to invite Professor Suresh Raj Chalise, who is known to all of us. We call him father of meteorology, who established Department of Meteorology and especially in Tribhuvan University. He's a former dean of Tribhuvan University and advisor to the Small Earth Nepal. With his presence, I was counting the several generations of the education system over here, and I can see 7 generations. So thank you, Professor Chalise, being with us.
Thank you. Very enlightening and very encouraging and inspiring talk. More than anything, I think, as the show has to go on, the scientific work also has to go on. When I look back, I won't go through the whole history. It will take maybe an hour or so I won't take that time. But what I see is that my initial days at ICIMOD, which lasted for nearly 2 decades, and also prior to that, from the late 60s to early 70s, my association with meteorology and climate, environment, as well as hydrology and glaciology. All these things came. I had to deal with all these things in my career as I progressed. But the main learning point has been that for us, particularly in developing countries, it is very difficult for us to convince our government to involve in long-term scientific studies. In fact, it is also true even in developed countries. Everybody is interested to fund a project, but they have, the donors have their own priorities. They change the priorities, and sometimes we can't continue some of the things which were very good going on. I'm very glad that, Professor Pomeroy has shared with us the models which have been developed with greater confidence these days. And I think this is where I think we have to probably concentrate also and also utilize whatever is available. And I think drawing attention of every collaborator, every actor, from the people upwards to the government and region and neighboring countries and the world. So this sort of collaboration is very essential because this is a global phenomenon. This is something which we may understand for a basic, but we have to understand the total in totality in terms of what is happening in global scenario. So the emphasis, the IYGP, the International Year of Glacier Preservation, I think it's a brilliant idea to bring all the people who are actors and who can collaborate together, have a very intense dialogue from the community. And the community is very important. We often ignore, the science people often ignore the community because they think that, you cannot communicate how your model is working and how, and we cannot learn anything like that. We go with a kind of, I don't know, forgive me if the attitude has changed, but we have to learn also from what people are doing. Professor Pomeroy mentioned some of the people, as in Himalayas also, in our part of the world also, that there are people at high altitudes managing water for centuries without anybody's support. So these kind of knowledges are extremely important. And I think at ICIMOD, we had tried, I hope this is still continuing, and learning from such projects where we may still draw lessons for the future. And I think we can do only so much as we can, what we are trained or what we are capable of. And that I think we have to do very well. The collaboration between the actors is extremely important. And I hope the International Year, as well as the International Week that we are going to celebrate, will bring everybody together. And I think this is where we can learn and share what we know and go further ahead. I will stop here because there are so many things that I could go on and on, but I think we have to respect time. I will stop here. Thank you, Professor Pomeroy, for coming and enlightening us. Thank you.
Thank you, Chalisi sir. Thank you, Madan sir. Both of them have been advising the Small Art Nepal for long, and I'm blessed to have them with us. So finally, we have closing remarks and wrap up from a very young glaciologist. I'm very excited. She's Sunwi Maske, Cryosphere Research Associate, ICIMOD. Thank you.
Namaste, everyone. I'm Sunvi Maske. And it has been an absolute privilege to be part of this open forum discussion with distinguished Professor John Pomeroy. This session has been truly insightful. Professor Pomeroy's insights into the interconnectedness of snowpack and downstream water resources were particularly impactful. And additionally, Professor Suraj Raj Chalise's points on the importance of local community involvement were also very important. This session has shed light on IYGP 2025 and the urgent need to address the accelerating loss of mountain snow and ice and more broadly, the entire cryosphere. This event, which is the key part of the key activities under the UNESCO chair in mountain water sustainability, and it also marks the first event of Nepal National Glacier Water and Weather Week 2025, chaired by the government of Nepal. As we look ahead to this Nepal National Glacier Water and Weather Week, a very long terminology. From March 17 to 23, we have an exciting series of discussions and activities planned, including the inauguration of the World Day of Glaciers on March 21, which marks a pivotal moment in our global efforts to protect these vital ecosystems, which is a joint effort by the government of Nepal, Kathmandu University, the Small Earth Nepal, ICIMOD, and several key partners. On behalf of ICIMOD, the Small Earth Nepal, Tribhuvan University, and our co-organizers, I want to express my deepest gratitude to Professor Pomeroy for sharing his wealth of knowledge on glacier science, hydrology, and climate change. His work continues to inspire many, including young glaciologists like me. And I would like to give a heartfelt thank you to Professor John Pomeroy, as well as Dr. Madan Lal Shrestha and Professor Suraj Raj Chalise for their invaluable contribution in this glaciologic sector, as well as meteorology, as well as hydrology in general, like this issue with climate change. And of course, to all of you who joined today, your insights, questions, and commitments make discussions like this much more meaningful. And the energy in this room also reaffirms how crucial collaborative research, policy engagement, and community action are in tackling the challenges posed by glacial retreat. As a young glaciologist, I find it incredibly encouraging to see the growing momentum around glacier preservation, the UN Decade of Action on Cryosphere Sciences, and the launch of World Day of Glaciers this year. Nepal has taken a leading role in advocating for mountain sustainability, and this session strengthens our collective resolve to keep pushing for scientific innovation, capacity building, as well as policy-driven solutions. Finally, a big shout out to the entire organizing team, technical support, they're not here at the moment, and everyone who worked behind the scene to make this event possible. Let's keep the conversation going and keep working together. And most importantly, let us leave here today with a renewed sense of urgency and a shared commitment to safeguarding our cryosphere. And with this as well, also, I would like to wrap up this session. And thank you everyone for your valuable time, insights, and commitment to glacier preservation. Thank you so much. Okay. Okay. We might still have some tea over, so yeah, let's head out for some tea and we can continue this informal discussion again. Not sure if the tea is there or not. Coffee. Okay. Sure. Yeah. Thank you to all our online participants as well. Thank you so much for your patience.